Okay, so, you know, I told you that anytime you add or subtract in anything in math, you can only add or subtract what's alike, and what's alike stays alike in the answer. But when it comes to multiplication and division, alike never matters. We can multiply and divide things that are completely different from one another. We might have some really weird, funky answers in the end, but it just never matters that they're alike. That's why we don't need common denominators when we're multiplying and dividing fractions, for example. It's not necessary. So when we multiply and divide with anything, we don't have to worry about like terms. What we do want to remember for this is that when we multiply, oftentimes it's the distributive property. You know, like if we had something written in parentheses like this, it means this whole thing times each of the terms inside the parentheses. And we could totally do that. We would actually add their exponents. So like here, we would say 2, we have x to the 6th, and no more y, so we have y to the 3rd. And then we do this again, and we have plus 5, x to the 4th, y to the 7th, because there's 3 and 4 y's there. And then minus x to the 6th, y to the 6th. Okay, and that would be it. Couldn't do anything else with that because they aren't like terms, so we can't combine them. All right, so, and you know, similarly, even the simpler ones, we have distributive property. This means 2 times each of these, right? So you would have 2x minus 6. So look at a problem similar to that right here. It's the square root of 2 times x minus square root of 3. And it doesn't matter, they're not alike. We can still multiply them. So what the x goes on the outside to show that it's being multiplying on the square root of 2. And since these are both radicals, we can say 2 times 3. And so we'll have the square root of 6 here. And that's it. So moving on, do some more of that distributive property here. If I multiply here, I get the cube root of 3x to the 3rd power, because there's 2 x's here and 1 x there. And then at that point, notice we're looking for things that have a set of 3. So this one can be simplified. We can bring that x on the outside and then call this the cube root of 3. And then we'll go to the next part and we get cube root of 24x again to the 3rd, because this is x to the 2nd right here. And this is x to the 1st, so we'll call that x to the 3rd. Now we want to look at this also. We want to see if we can simplify the 24. 24 is made up of 8 times 3, and 8 is one of the common cubed numbers. It's 2 cubed. So the cube root of 8 is 2. We'll bring that out here. And then the cube root of x to the 3rd is x. And the part we couldn't complete was the cube root of 3. So we have cube root of 3 here. Okay, so right now we have 1x cube root of 3 plus 2x cube root of 3. So 1x plus 2x is 3x. So our final answer then would be 3x. And when you add, what's alike stays alike in the answer. So it's cube root of 3. That would be your final answer. So I think you got the gist of that. I'm not going to do this next one because it's kind of the same idea. I want to get on to this next part. Do you remember doing FOIL, like when you have like 2x plus 3 times 5x minus 1, and it's usually it's taught with FOIL where you go, actually I'll do one down here. First, outer, inner, and last, where the first in each set gets multiplied, so you have x squared here. And then the outer edges, which would be the left edge, is x, and the right edge is 4. So you have a positive 4x. And then the innermost, positive 4 times x. And then the last in each set gives you 16. And usually when we did FOIL, we would go ahead and combine like terms. Though usually it was the middle terms. So you'd have like x squared plus 8x plus 16. And that would be your answer. Similarly, the one I wrote up here, so if you did first in each set, you would get 10x squared and